Good day. We are plowing our way through electrochemistry. We have finished the first section, so it's time for a bit of a review. On day one, we talked about oxidation numbers. This is really just a way of keeping track of electrons. And so this should be easy. Any element that's in its elementary state is going to have an oxidation number of 0. That means we're looking at atoms, not ions. Any simple ion will have its charge, and so if we look at something like sodium, its oxidation number is +1. If we add sulfide, that would be -2. But where it can get more complicated are when we have complex ions. We'll get to that in a moment. Oxygen, normally -2, but in peroxide, -1. And you have to know what peroxides are. Hydrogen, normally +1 when it's bonded to a nonmetal, but when hydrogen is behaving as a nonmetal, it's a hydride, and that means it's bonded to a metal, and hydrogen hydrides is a charge -1. So the other oxidation numbers are things you have to calculate. And so in a lab, you dealt with manganese, which has all kinds of different oxidation states. And you have to be able to calculate that based on all the known elements in a complex ion or compound. Then we got to redox reactions, and we said, hey, Leo the lion says grr. Loss of electrons, oxidation, gain of electrons, reduction. So redox reactions have to involve reduction oxidation happening at the same time. Now the material that's reduced is called an oxidizing agent because it oxidizes the other material. It oxidizes by taking electrons. The material that's oxidized is called a reducing agent because it gives its electrons to the other chemical and reduces it. So redox reactions include synthesis, decomposition, combustion, single replacement, but not double replacement and not neutralization. So in these first 4 types, we are looking at changes in oxidation states. Now, in order to be able to balance redox reactions, you first have to be able to balance half reactions. And there's a table of reduction reactions that you don't have to memorize, and you should know all the information it gives you. But you should also know the steps for balancing those half reactions. And remember, it's called major hydroxide, and the only time you have to worry about going those extra steps or if it says basic conditions. But the major hydroxide means major OH minus. So major means you balance any elements that are not oxygen or hydrogen. Then you balance the oxygens by adding water molecules. You balance the hydrogen by adding H plus ions. And then you have to make sure you balance the charge by adding electrons to the side that has the higher charge. Basic, all you're doing is you're adding the same amount of OH minus to both sides because we don't want to throw our balanced half reaction out of balance. Once we've done that, typically we stick with the half reaction method. We're balancing out the electrons, and those steps are outlined right here. If you're wild and crazy and want to try the oxidation number method, you're more than welcome to, but it can be a little more confusing. Once we have balanced chemical equations, then we can do things called titrations, stoichiometry, and that means we'll have a volume and concentration of a known material, and we will have the volume, typically, is what we've experimentally determined, of a material with unknown concentration, and we use stoich to find the known concentration. We can do other things with it as well. Now, in this video, I haven't included how we predict redox reactions. You'll want to go back to that as well because that's one of the toughest things we do. Make sure you have a handle on that as well.